Hi, welcome to a video on probability density functions. We're just going to sort of introduce the idea. These are also sometimes known as probability distribution functions, and we're going to, and the common way to abbreviate this is by just using PDF. Okay, so the first thing I think about is that a PDF is just a function. So anything of the form y equals f of x, is a function. These probability density functions can have all different sorts of looks. They could be sort of a constant function. We could have a PDF that is like an exponential function. We can have all kinds of shapes, but they need to be functions. So that's what a PDF is. It's a probability density function. Okay, so the first thing we know it's a function, but there are some other conditions on this. A condition is that this function has to be positive. It's got to be above the x-axis. So each of these examples I've drawn here would meet that condition. So PDF has to be a function, has to be above the x-axis, and then here's the tricky one. The area under this function has to be 1, representing like 100% of the data. In calculus, we would say that the integral of this function, because that's how we get our area, is going to be 1. Alright, so the area underneath these functions has to be 1, representing 100% of the data, or the total probability. And then if we were to take a subset, just a section of the domain, so if we have a subinterval AB is a subinterval of the domain of the function, then what we would know is that the probability of our value being between A and B would equal the area under our function on A to B. So if we use one of these sort of graphs above here, if we just sort of follow back up here, if we just pick a probability density function, how about this one here on the right, and we say, hey, let's look at this interval from A to B here, then this area underneath here from A to B would represent the probability of some value x being in that interval from A to B. Okay, so those are sort of the conditions of a function being a probability density function. Let's just take a look at a potential example just to sort of give you more things to think about here. So let's say that we are on an alien planet, and the aliens have all different heights. And so let's let x be a random variable. And this x is going to represent the height of a random alien. Okay, and so the heights of aliens, of course, are going to be different than the heights of just regular people. Who knows? They could be all sorts of heights, but let's just say maybe they sort of range in height a maximum of 80 inches, and let's see, that would put 40 in the middle here. And so let's say that they have a probability density function that looks sort of like this. Okay, so this is the PDF of our alien heights. So down here at the bottom, these are the heights of our aliens. And on the vertical axis, this is the probability density. Okay, so you can see that our probability density function is above the x-axis. It's positive. And for example, if we wanted to find out, hey, what's the probability that we choose an alien and their height is greater than 70? Well, on this graph here that we have, here's 70. And here's to 80, so because that's the max height of our alien, if we calculated this area here from 70 to 80, that would give us the probability of choosing an alien that's one of the tall aliens that's greater than 70. Okay, so this shaded area would represent the probability that we get an alien with a height greater than 70. Okay, so these probability density functions, in this course, we're not going to be finding them. Rather, they'll be given to us, and we'll just be calculating some probabilities from them. But essentially, they're very similar to histograms. If you've worked with histograms, where histograms are more like a bar chart. So if you were to sort of chart the heights of aliens and so on, you'd have something more like this. And sort of a similarity would be between histograms and probability density functions in that they would show the distribution of heights of these aliens, and they would show you the range of all the possible heights of these aliens, and they would give you the likelihood of each height. So the difference in the main difference between the histogram and the probability density function is that we've created a function that models those heights. So instead of just a set of bars, we have an actual function. We have an equation that we can use. And then with calculus or other methods, so long as we can calculate the areas, we can come up with the probabilities. And that's what we'll be doing next. Okay, I hope this has been helpful.